First time that I'm going to have some interaction with the students of Anant University, and it will be a pleasure. So for next 1 hour, of course, I'm going to enjoy the session, and I will try to make the session enjoyable for students as well. I would like to just share my presentation, and please confirm that it's visible.
Yes, sir, it's visible.
Yeah, fine. Thank you. I would like to make a few things clear. Say the title of the presentation is Learning from Failures, a Geotechnical Perspective. And this is being offered to you under the Disaster Management Lecture Series being organized by your university. And there are going to be some 4 or 5 such sessions in the month of February and March. That's what I'm informed. And the other thing which I'm informed is that I'm talking to the students of architecture and disaster management. So what I have tried to say include in this presentation, I have included a few failures in the field of civil engineering, and mainly which are happening below the ground level, or because of the processes which are happening below the ground level. So, again, I was not aware of the feed level of the students, that from which semesters these students are actually coming and they are, say, getting registered here. So I have tried to make it as informative as possible. And of course, what I have covered here are all very advanced techniques and methods and their results for, say, observation of the failures of facilities, and also for deriving certain conclusions for some remedial measures. It would be difficult for me to go into the details of the analysis and some of the calculations, particularly some statistical analysis. And so I will just make it more informative to share the information with you for some advances which are taking place in this field. And if somebody is interested in getting more details, he is always welcome to have more discussion with me on certain topics, and I can provide him with more details. We are going to discuss about the failures of the civil engineering facility. And facility can be anything like any of the buildings or dams or tunnels or any of such, say, structures. And the failure is defined this way. It is an unacceptable difference between the expected and observed performance of the facility. So whenever we are making any facility, say you are constructing one residential building, then always there are certain expectations. You expect certain kind of performance from that building. And when you commission that building, when you start occupying that building, you start using that building, then you are definitely expecting certain level of performance from that facility. And when you are experiencing certain difficulties, certain problems while using that facility, and you are observing that certain things are going wrong, then you are not happy with the performance. And then we say that it is a failure. Even if the error is very small, even if the mistake is very small, even if there is a little problem with the performance, but then also it will be considered as a failure. So engineering failures are really very hard to define. Failures can be as large as catastrophic disasters, which we all have seen in the year 2001, what really happened in the city of Ahmedabad when the Bhuja earthquake happened. I don't know, but many of you, if you are in the college, then you must be in the age range of about 18 to 20 years. And so when this earthquake happened in 2001, you must be a very small kid. But our age level people have experienced that, and it was something which we never imagined. So it was catastrophic disasters, and which was giving serious threats to the public safety. Many buildings collapsed, many people died. But on the other side also, there may be, say, simple shortcoming in the behavior or the function of the structure, and that will also be treated as the engineering failure. And one thing I would like to just inform you that the engineers and the architects, they are always regarding these failures as their greatest enemy. They don't like such failures because, of course, it has got something to do with the cost also, some certain, say, penalty or certain damages to be paid to the clients. But otherwise, also the performance problems are a great enemy for the engineers. But what I have learned over the years that these failures are actually very good teachers, because without the failures, it is very difficult to learn some of the things. Because say, I consider this 2001 earthquake as the live laboratory where all the full-scale buildings were put to the test. And when the ground was shaking, and it continued shaking for about 1 minute, serious shaking happened, and all the buildings were tested. And the buildings which collapsed were having certain problems somewhere. We can say that. So when these failures occur, of course, we don't like failures and even damage to the properties and also to the lives of the people. But these failures are really great experiences for learning. And when such failures happen, they teach us good things. And really, we are having certain current advances which we have learned or which we have, say, again started practicing only when we knew lot many things from the failures. So studying well-documented failures is important as the findings can be used to improve the designs and performance of structures. We can always improve the design, we can always improve the performance when we are aware of the certain effects of the failures. Let us have a certain idea about the types of failures which can happen. So there are certain failures which can happen during construction. When the facility is being constructed, certain materials are being worked upon, and there can be failures before the building is completed. There can be failures of formwork, there can be failures of certain support system, there can be failure of the constructed part of the building. This can happen during construction. The second type is a kind of failure which happens after the building is completed. And it is a failure of the services. Whatever services that we are expecting from the building, suppose if it is an institutional building like educational building or a certain high court or some sports complex, if that building is not able to deliver the kind of services that it is supposed to offer, then it is a failure. And sometimes the third kind of failure is when the maintenance is not proper. And you would not like certain things which are appearing in the building, like some leakages are happening, some drainage problems are there, water supply is not coming properly, or ventilation is not proper. So these are all failures actually due to the improper maintenance or some problems with the designs of the buildings.
Sir,
We are going to focus on the geotechnical failures. And I have listed some of the causes for these geotechnical failures, like earthquake or the load transfer, because finally, say, when the building is constructed, it's going to rest on the soil. It is going to rest on the ground. And it is going to derive its support from the ground. So the building loads are to be transferred onto the ground, and it is going to be the ground which will finally receive the load, and it will support the building. So there can be failure. Hello.
Sir, we cannot see the slides with the list.
The slide is not visible.
the slide is not
on the
changing.
first slide.
It is on the first slide only.
Oh. Is it not changing?
No, sir. It's stuck on the first slide.
Yes, sir. It's stuck.
I'll put it again. Is it visible now? Second one.
Now it changed. Yes, sir.
Now again it is changing. Or is it second one only?
Second one only right now.
Sir, can we apply a full screen and then change the slide with enter key only?
Full screen and
Able to, yeah, so you can press F5 or yes, okay.
Now we are on slide 4, sir.
this one.
You can press F5, sir.
Oh, it is full screen. It is changing on my laptop, but it's not changing there.
No, it's not changing. We are on 4th slide and we are able to see the list of slides as well.
Oh, why it is happening?
And there is an option in the right side bottom corner to apply full screen.
Yeah, that is okay. Is it
Now
now
we
changed?
are on a cause of geotechnical failures.
Yeah, that is the slide. Now I'm changing it to the next one. Is it changing now?
No, so I think, sir, there is a lag, so maybe it'll change after 5 seconds.
It is taking time. It is taking few seconds, like 4-5 seconds to change the slide.
Okay. So are you now able to see this the terms soil mechanics, etc.?
No, we are only able to see the causes for geotechnical failures.
Oh, why it is happening?
Sir, you can share the presentation with me and I will run the presentation. And you can speak along with the changing slide.
But generally, it doesn't happen that way. I don't know.
Or maybe, sir, you can stop sharing and start sharing again.
I'll do that. I'll do that again.
Yeah.
Are you able to see now causes of geotechnical failures?
Yes.
Yes, sir.
And is it changing now?
No, I think it's still there.
Sir, maybe there is some internet issue, so it takes some time to load the slide, and then we can see it later.
Sandip sir, or you can mail the presentation to Chintan sir.
It's a huge slide. I don't know how it will happen.
Now it is changing. Now we are
on the terms. Yeah, so
term.
I think it's taking about 10 seconds.
Are you able to see it here?
Yes, and now we are seeing soil. Yeah, again it changed. So now we are at soil
Yes.
layer. Yes.
Now, if I keep it here only, will it do? Will it be okay?
I mean, I didn't get you, sir.
No.
Yeah,
say,
now it's changing well.
I'll not make it full screen, but are you able to see the things here?
Yes, 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 sir. So I think that view was also okay. That 80 or 100% that previous. Yeah, this one's also fine. We are able to read.
You are able to read this, then I'll keep
Yeah.
this view only open.
Okay,
Because
sir.
when
Okay.
it is made full screen, I think something goes wrong with the connectivity. So if I
Okay.
change it here,
Yeah.
now
Now we can see the soil layer.
Yeah, so I'll go back, and this is what I was discussing. Okay, can I start?
Yes, yes, sir. Please continue.
Okay, fine. So actually, we are going to focus on the causes of geotechnical failures. Now, I have listed all, say, many of the causes which result in the failures of the part of the building which is below the ground level, and mainly these are foundations. And for some of the applications, it can be certain other parts of the or the components of some structures. If you are, say, taking example of the retaining wall, or say bridge approaches, or the part of the tunnels or bridges, then it would be affecting a bit in different way. But here again, say it would be difficult for me to include all 9 causes. But I have picked up few causes which are happening very same on most of the cases, and which are very common failures. So, but before that, I would like to just discuss some basic terms, because I don't know whether all the students have studied the geotechnical engineering at your place or not. So there are 3 terms which we'll be discussing again and again. One is what is soil mechanics, and what is soil engineering or geotechnical engineering. Now, this is a representative sketch of a soil layer. So what you are able to see here is a ground level here, and there is one layer of the soil, and then at certain depth the rock layer starts. And this exactly is the sequence of the layers in natural geological strata. Of course, the depth of the rock layer would be different at different places. The thickness of the soil layer would be different at different places. It may be a few meters to hundreds meters or 2-3 kilometers of the soil layer. And at some of the places, the soil can be totally absent also, and the rock is just appearing on the surface, what we call the outcrop in geological terms. For Ahmedabad, I can tell you that the thickness of the soil layer is almost 2 to 3 kilometers, and the rock is at a very great depth. And that was one of the reasons why there was huge damage during the earthquake of 2001, because there was, say, soil and soil up to about 2 to 3 kilometers. We'll try to understand the word soil mechanics. This is a photograph of Carl Terzaghi, who is regarded as the father of soil mechanics. And according to Terzaghi, the soil mechanics is a science of the laws of solid mechanics and the hydraulics to solve the engineering problems, dealing with the sediments and other unconsolidated accumulations of the solid particles. See, what really happens whenever the rock outcrop is exposed to the environment, it is subjected to certain weathering agencies. And because of the mechanical and chemical disintegration of the rocks, there are certain particles formed, and which remain unconsolidated as accumulations on the surfaces. And this is nothing but the soil. These are the sediments. We are able to see such, say, eroded sediments in the riverbed also, even at the, say, foot of certain hills. And these particles kept on forming continuously as a natural process. It keeps on happening in the nature. And because there are solid particles, we also apply the solid mechanics rules there. And there is groundwater also. So the fluid mechanics principles are also applicable to the soil. And So we can say that the soil mechanics is actually a combination of the solid mechanics and the fluid mechanics. And when it comes to geotechnical engineering, which is also known as geotechniques, is a branch of civil engineering concerned with the engineering behavior of earth materials, mainly the soil and the rock. When we are applying the, say, theory of soil mechanics for the solution of many of the engineering works which are involving soils and rocks, that becomes geotechnical engineering. The applied soil mechanics, you can consider that as geotechnical engineering. So we are actually going to discuss about that part. When the soil mechanics is applied to solve some of the engineering problems involving the soils, that becomes the geotechnical engineering. And if the failures are happening there, then what really happens and how it can be avoided, or what can be the remedial measures that we will discuss. We start with the first one, the geotechnical failures induced by the earthquake and learning thereof. See, earthquakes, this is a wonderful statement which my PhD guide used to mention again and again. Earthquakes will not tolerate the weak links wherever they exist in the structural system. And here, the structural system is actually, say, extending right up to the bottom of the foundation. What we are able to see above the ground is actually a building. Of course, definitely a structure, and there is a structural system which is being designed by the structural engineer, which is imagined by the architect. But it is also there below the ground level, and that is in the form of the foundations. And if there is a weak link, then that will definitely break, because nothing remains unshaken during the earthquake, right? Now, see, if you consider the say map of India, this is a map which is showing the earthquake risk. Almost 56% of Indian land is vulnerable to the earthquake hazards. And you can see that there are 5 zones. Zone 5, seismic zone 5 is giving you the maximum risk, which is covering about 12% of the area for the country. Seismic zone number 4 is covering about 18% of the area of the country. And seismic zone number 3 is about, say, 26% of the area. And this is as per the IS 1893 of 2002. That was after the earthquake when it was revised. Earthquake of 2001, it was revised, and this was the revised map of earthquake risk in India. So almost 56% is vulnerable to the earthquakes. And so we must be very careful in designing the foundations for the buildings, particularly when they are in seismic zone number 3, 4, and 5. Ahmedabad is definitely in seismic zone number 3. What I'm going to cover in this presentation, I will be discussing about certain, say, failures of India, and of course our own city, Ahmedabad also, where I have done a lot of works. In India also, there are certain geotechnical failures which have happened, and also some failures which have taken place at the world level in different countries. And I'll be mentioning about these failures, and we will try to derive certain, say, very good lesson out of that. See, this is the study area, which is Ahmedabad region. What you are able to see here is, say, Ahmedabad Municipal Corporation boundary, which is shown in black line here, what you are able to see. And outer area is actually belonging to Ahmedabad Urban Development Authority, that is AUDA area. Of course, now the AMC boundary is a little bit expanded in last 2 years. This is the map actually of some 2010 or 11. And that time it was, area was about 220 kilometers square. Now it is almost doubled, 410 kilometers square. I think that is the figure. Population is more than 5.5 millions, and seismic zone 3 as per IS 1893 2002. I'm going to discuss about certain failures which have taken place in Ahmedabad to start with because of the earthquake. See, and I'll be focusing on the Bhuja earthquake of January 26 of which happened on January 26 in 2001. I was working with Nirma University that time, and on that day, because it was the Republic Day of India, we were on the grounds at say 8:45 for the flag hoisting, and suddenly before the flag hoisting, the ground started shaking. At least for me, I can tell you that I had never experienced the earthquake before that, say, experience. So many of us could not realize that what is really happening. But we felt that the ground is shaking, something is going wrong, and we were not able to even stand properly. We were not able to even keep up the balances. So we started holding the hands of each other. But it was a huge, massive earthquake having the magnitude of 7.9 on the Richter scale, which happened at the Bachau. The epicenter of that earthquake was at Bachau near the city of Bhuj. And it affected some of the areas of Gujarat to the worst possible extent, which were, say, Anjar or Bachau or the Bhuj, which were nearby areas, Gandhidham, Rapar, even Morvi, and also the city of Ahmedabad. Now, what is different here? See, Anjar, Bhuj, Gandhidham, Rapar, all these cities are very near to that epicenter, near that Bachau village, which was totally destroyed. But Ahmedabad is at, say, a distance of about 250 kilometers from that epicenter, that Bachau village, almost 250 kilometers. And a huge damage occurred here in Ahmedabad. Vadodara city is also, say, about 270 kilometers from that Bachau village. But Vadodara suffered minor damages only. You take, for example, say, the city of Rajkot, city of Jamnagar, which are very close to that place, Bhuj. But Rajkot also suffered very minor damages. Jamnagar also suffered very minor damages. So what really went wrong? What really went wrong, right? And I will just show you some of the, say, slides. I think you must have seen that in some of the magazines or some of the websites. This was the worst affected areas. These were the worst affected areas in the east and west part of Ahmedabad. This is a photograph of the Akshardeep apartments, totally destroyed. This was the Mansi apartment. I think there is now a Swaminarayan Temple, which is existing there. But this was the entire one part of the building came down within seconds. This is the kind of typical geotechnical, say, feature that we are seen in the desert of Kutch, even near Bhuj city. These are known as sand boils and also known as liquefied sands. This was very evident there in many of the areas this was seen. And there are possibilities that this must have happened at few of the places in Gujarat also, where this kind of soil is present. See, these are, say, outcome of a huge study that was undertaken that time, the collapses of buildings in Ahmedabad city. And you are able to see two circles, one in the western side, one in the eastern side, which are showing the concentration of the damaged buildings. On the west side, I can tell you that the Paldi was worst hit, and many other areas in the western Ahmedabad. And in the eastern Ahmedabad, the Maninagar area and Kokram Ahmedabad and some of those areas were worst hit. So why not all other areas? Why the damage was not uniform all over the city of Ahmedabad? Why only a few areas were having more damaged buildings? So that is one question that we can always ask. And the reasons which were put forward for the building damages in Ahmedabad, they were put in certain categories. Like a few of the engineers were of the opinion that the buildings which really collapsed, they were having improper structural system of the buildings, or they were there were some improper construction practices, or some of the houses which collapsed, they had some modified components which were made by the occupants, or some of the building bylaws were not followed by the architects and engineers, or by the say houses which were made, and certain violation of the rules were made. and so the stability of the building was affected. All these reasons were put forward, which were connected with the either say inferior materials or inferior design or inferior workmanship. But more than that, there were also certain possibilities raised regarding the geotechnical failures contributing to these damages. Whether there was occurrence of resonance. I would just like to define this term resonance here. Say, I don't know whether you are aware of the word natural frequency. Natural frequency is there with the soil also, and each building is also having its own natural frequency. It's a dynamic property. The building, when it is designed and provided with certain materials and provided with certain openings, depending upon the stiffness and the total load of that building, it will derive one particular natural frequency. And the soil on which that building is constructed, that will also have its own natural frequency. Now, if these two frequencies of the soil and of the building, if these two are matching within a very short range, narrow range, then what is known as resonance will occur. Both frequencies of the building and the soil will match, and then the building will start shaking infinitely, and a kind of a resonance will occur, and that building will certainly collapse. So if you have constructed a building on a kind of a soil where the building is having the same frequency as that of the soil, then the resonance is quite possible in that building, even if it is constructed with no other problem. You have used certain good design, you have used certain good workmanship, there are say superior quality of materials being used, so absolutely no problem with that building. But if this resonance occurs, even that building will come down, right? So this can be the reason where some very good buildings were also collapsed during the earthquake. There can be presence of soft soil, and in Ahmedabad, at number of places, the presence of soft soil is now established. I can give you some because I have surveyed a number of areas, because that was my major PhD topic also. I have surveyed the entire soil profile of Ahmedabad city, and particularly certain areas I can give you as say like Maninagar is having a very soft soil, Paldi is definitely having a very soft soil. Certain areas within the old city area are also having soft soil. So if you are building certain structures on this soil without really making it dense and compacted, then the buildings, of course, the vertical say equilibrium will happen only for the vertical forces. But the moment when the horizontal force comes, like during earthquake, the horizontal forces say attack on the building, and that time the such soils will give away, and the building will come down. Even the presence of the old buried lakes, say it is available in the historical literature of Ahmedabad city, that there were a number of lakes, more than about 120 lakes in city of Ahmedabad. And now there are only about say 15 or 20 lakes. And many of these lakes have been buried by say some waste material from either the construction or from some industry. And all these lakes are now filled up. And this filled up soil is still consolidating. It is still in a kind of medium dense or lightly consolidated state. So if you are constructing building on such filled up soil, then also it's a danger. And one more thing is that there is a possibility of liquefaction. Of course, for Ahmedabad, I can tell you that fortunately, the groundwater table was at a great depth at that time. So it was at a depth of about 80 to 90 meters or even more than that. But the soils which are there in the city of Ahmedabad below the ground level are definitely kind of soils which can be affected by liquefaction. The liquefaction can happen there, and we have the river Sabarmati flowing in between the city areas. And the areas which are near to this river, flowing water, they really have the groundwater at a shallow depth, within say about 15-meter depth. Near Nehru Bridge, it is at about 8 meters. Near Vasna, it is at 12 meters. So these areas are definitely having kind of soils which can undergo liquefaction. Liquefaction means during the earthquake forces, the water which is present there will turn this solid ground or the soil into liquefied soil, जिसको हम हिंदी में दलदल बोलते हैं, उस तरह की soil हो जाएगी. And if it becomes liquefied, then how it can support the buildings? Momentarily, it will become liquid, and liquid will not support any building. So that is a possibility. But fortunately for Ahmedabad, that the groundwater was at a great depth. But now, if you see, now the Sabarmati River is remaining, say, perennial for 12 months. It is full of water, and the recharging of the water is happening. Groundwater is rising every year now. It's not a problem. Earlier, it used to deplete. Depletion was taking place every year, but now it is coming up. And if it reaches within the shallow depth, it was there, say in 1970, I'm aware of that data, when many of the areas on both the sides of the, River Sabarmati, on both the sides of the banks area, the water table was available at 7 meter to 8 meters. If that time, if the earthquake would have happened, then there were chances of liquefaction because the soils are favoring. The similar kind of soil is there in Delhi also. I was with IIT Delhi, and that time we have surveyed number of areas in Delhi also, and particularly the Trans Yamuna area, where the Fafadganj and other areas are there. It is a typical Delhi salt, and it is having water table at a depth of about 2 meter to 3 meter or at 5 meter. And if a huge earthquake like this strikes Delhi today, all these areas are likely to be liquefied. It's a big danger there for the national capital region. Particularly, say, this is a schematic diagram of how the waves are coming from the epicenter. It is coming from the epicenter, and it is traveling through certain media, that is through the Earth's crust. And then when it approaches the surface, it becomes almost vertical, and then it rises up. Say for site A and site B that you are able to see here, it is rising up, and it is disturbing the facilities which are there on the ground level. So there are two things which are important. See here, I have listed 3 groups of factors which can cause the earthquake damage. First one is definitely the earthquake source and the path characteristics. So source is from the epicenter, and the waves which are traveling through this particular path, the characteristics of both these things will affect. But more than that, the local geological and geotechnical site conditions are really causing more damage. So at site A and site B, what are the geotechnical and geological conditions, say, occurring there, would be really, say, making the effect. And then the structural design and the construction features of that particular facility, which is at site A and site B, that will also be responsible for the damages. So we are concentrating here on the second factor, that is local geological and geotechnical site conditions, based on which we can do some kind of a zonation, microzonation, for the seismic damages. So what really we are trying to do here, on the basis of certain earthquake parameters or certain geotechnical site conditions, we are dividing a huge area, say like Ahmedabad city, into smaller zones, where on the basis of the probable risk, we are dividing the huge area. What we can do, that in the Thaltej area, the risk is less. In Paldi area, the risk is more. In the, Kokram Ahmedabad area or Maninagar area, the risk is more. In the airport area, the risk is less. This is what is done is a kind of a microzonation. And it is known as seismic microzonation. So after 2001, what I would like to inform you that the seismic microzonation is being done on a very large scale for a number of cities of the country, and that is being used as a guiding tool for even planning and designing of the housing societies in these areas. I'll just like to show you some of the microzonation works which are being done. These are all microzonation efforts in India. You can see at Delhi, at Bhuj, Ahmedabad. Ahmedabad, of course, I was involved with the professor from IIT Delhi. You can see Rao and Trivedi both have worked in Ahmedabad. I'm presenting that work here right now. In Surat also, Rao and Thakur, then in Mumbai, Raghunath and Iyengar, in Bangalore, Sitharam and the team, Chennai, the Bhuminath and Sugandhi, and Sikkim, Guwahati, Dehradun, Rajiv Ranjan and Gulati have worked in Dehradun. And right now, about 40 cities of India have been undertaken for the seismic microzonation work. And at many of the places, you must have heard the name of the Institute of Seismic Research, ISR, which is there at Gandhinagar. I would request the faculty of your university to arrange a visit to this institute and see some of the advanced instrumentation that they are having. They are having the earthquake information system. Whenever there is any earthquake happening in Gujarat or in other parts of the country, immediately they are receiving it. And of course, that is also connected with the CMO office, Chief Minister office. And for investigation and for doing this kind of microzonation, they have purchased some huge equipments, advanced equipments, and some of the equipments, each equipment is costing more than 1 crore. So you must go and see. I think some of the equipments are there with ISR, which is not there with any of the institute in country. And these are very advanced equipments. So even to see the instrumentation, I think you must visit the ISR once. And there are many cities being handled. Even the Dholera area is totally, surveyed by the Institute of Seismological Research, and many other cities are being, surveyed by them. So here, how it was done. What we really did, almost more than 1,400 boreholes were drilled in the soil. Borehole data was generated. Borehole is a kind of a small hole that we are making in the soil, up to about 10 meters, 15 meters, or 20 meters. And some of the boreholes were drilled up to about 100 meters. So here you can see some say red squares, some purple rounds, some triangles, some green squares. These are all different types of boreholes having different depths and even the density in these areas. And from the samples which we collected from these boreholes about the soils, these were tested in the laboratory for their properties and how they are going to behave under the loads. And based on that, we actually prepared certain cross sections. I think you are architecture students, so you must be knowing about the section lines. We try to make even the sections of the buildings, and we try to show the details of the buildings in the sections. So here what I had done, there were certain section lines in the eastern part here. This is the eastern part. This is the river Sabarmati here, and this is the western part. And we actually made certain, sections here. This is the first one, blue colored section that you are able to see. And this is the kind of a soil of different like gravelly sands or clay sands, clay silt, sandy sand, silty sand, and even the filled up soil at the top. These were the different types of soil layers identified. It was done for almost all areas in Ahmedabad. You can see here for the next some of the east. So I kept the E1, then E2, E2. There were 8 such sections on the eastern side. There were, say here, you can see that 4 sections I have shown here, and the kind of soils which are there. Because if we are aware of the soils, then only we will be able to see the things. Then on the western side, you can see that on western side, the different sections and different soils which are there. I'm not going into the details of how these soil groups have been labeled. It is as per the Indian Standard Soil Classification System, and these classes of the soils have been derived at. by performing certain laboratory tests, we generally identify the soil group, and we are able to prepare such sections. Based on the soil layers shown in the earlier sections, we are able to find out what are the soil layers in certain depth range. See, for Ahmedabad city, in most of the areas, the topsoil is up to 2 to 3 meter, which is generally consisting of the silty sand and clayey silt. The blue colored areas are showing the clayey silt, and the yellow colored areas are having silty sand. As far as the liquefaction is concerned, this silty sand is really dangerous. And this slide, you can see that from 3 meter to 6 meter for most of the areas of AMC and Ouda area on the western side, what you are able to see from 3 meter to 6 meter, the entire depth is covered with the silty sand. And this is a kind of a dangerous layer because this favors the liquefaction. It was fortunate for all the Ahmedabadis that there was no groundwater here. Had it been filled with the groundwater in, say, all the voids in the soils, then the liquefaction would have taken place. And the soil, when it is liquefied, the buildings will not stay there. So that would have resulted in a large catastrophic failures here for the buildings. But we were saved that the groundwater was not there. And after this, some of the dynamic testing were also performed. I'm just showing you this equipment, which is now widely used in India for doing the dynamic survey of the soils, particularly for earthquake-related properties. This is the engineering seismograph with certain accessories. Here on the say left top, you can see the entire setup of the building, entire setup of the seismograph. Say left below, what you are able to see is the main computer system, and on the right you are able to see the source application unit, and these are all the geophones which are arranged in the line. Say there are about 24 geophones at 3 meters center to center, arranged for a total straight length of about 75 meters. And then we try to investigate the depth of the soil for dynamic properties, earthquake-related properties, from which we can divide the zones whether it will have more risk or less risk. And when we did, say, we use this equipment in Ahmedabad for almost about 120 locations, and from that we have prepared this kind of shear wave velocity spread. This is the color contours for the shear wave velocity value at 10 meter. It is the shear wave which is damaging the buildings the most, because that is traveling through the soil and it is damaging the foundations of buildings. So shear wave velocity at 10 meter depth, and of course the velocity is as high as 569 kilometer per hour. So that is dangerous. That is dangerous. And this way it was worked out for 20 meter depth also, and even for 40 meter depth also. There was no rock for this. And then there is one parameter, average shear wave velocity at 30 meter, that is known as VS30, which we are using for the design of the buildings. And if this value is available, I think you can make the buildings safe, safe against the earthquake pressures, right? So, or you can derive certain conclusions regarding the design parameters, that if I use certain parameters in this building, the building will remain safe in case of the earthquake. So you are having certain study outcome from the soil, and you are making your building safe against the soil effects. Similarly, there is another building, say another equipment, the vibration monitoring equipment, which is known as the micro tremor, and which is also helping in deciding the natural frequency of the soil. Using this particular equipment, we did some analysis for about 140 points in Ahmedabad, and it gives us the amplitude of the vibrations in horizontal and vertical directions. And this is also the color contour for the H/V amplitude ratio, which also we are using for the dynamic design of the buildings. And the values which are presented here are the realistic value as tested on the field for the soils which are there naturally existing. Even the predominant or the natural frequency which is there. Now I had explained earlier that if the building frequency and the soil frequency are matching, the resonance will occur. And it is quite possible, my assumption is like that many of the buildings which collapsed in 2001 earthquake, they collapsed because of the resonance that occurred. Now here, this is a kind of a graph where the frequency of the soil is given, ranging between say 0.385 to almost 3.48 for different areas of Ahmedabad and Ouda area. Now, if you are aware of the frequency of the soil, then do not keep a building on that soil which is having the same frequency. So you can avoid the resonance, right? If the soil frequency is say around 1.5, then you go for a building frequency of 4.5 or 3.5. Don't keep it near to 1.5. So you are avoiding the resonance at that place. You are keeping the frequency of soil different because you are aware of the soil frequency from this graph. And the building that you are now proposing or designing with the kind of materials and the other layouts, you are keeping the frequency of that building totally away from the soil frequency. So the resonance will not occur and that building will not collapse in the event of earthquake. So these are some of the very good experiments available, and people are using the same on a wide scale, and they are making such contours, microzoning maps for various cities. This we had prepared way back in 2006. These are again modified by ISR in the year, I think, 2016. These maps are available with the government of Gujarat, R&D department, even with the Ahmedabad Municipal Corporation for Ahmedabad region. And these maps must be studied prior to designing and construction of building, just to make the, so this is what we have learned. Say the failures occurred at the time of Bhuja earthquake in 2001, but after that there was a huge effort done for the microzoning of the areas, and now we have certain maps available with us, which can help us to make our buildings say safe and steady. Similarly, we can have some of the geotechnical failures induced by the liquefaction of soils and learning thereof. See, when liquefaction occurs, liquefaction was known to the world somewhere in 1964 when the earthquake of Niigata happened, and many of the apartment buildings just overturned because the soil below the apartment buildings liquefied and there was no support available for the apartment. You can see in the photograph here that some of the buildings are totally overturned. And of course, what is surprising is that the nearby building is just standing safe and there is no effect. But these three buildings are totally, say, overturned. Now that is the effect of the localized liquefaction that occurs during the earthquake. Now, when this occurs, it can happen in the river also. This is the lateral spreading happening because of the liquefaction, when the soil spreads laterally, and because of which the foundations are also moved, and the kind of damages which can occur to the bridge spans, which are shown here. That same thing happened at the Niigata earthquake in 1964. This is again in say Alaska, 1964 earthquake, when huge damage occurred to the infrastructure facilities, particularly the highways and roads were greatly damaged because of the lateral spreading, because the embankment or the roads were pulled apart and there were huge cracks developing. Say almost the width of the crack was more than about 1 feet to 2 feet at the top, and extending up to a great depth, about say 2 meter to 3 meter deep cracks occurred because of the earthquake and liquefaction. The damage to the dams, and which is resulting in the landslides and total collapse or partial collapse of some of the dams occurred here. What you are able to see is the San Fernando Dam, which occurred in 1971. And this was resulting in flooding also in the very heavily populated areas, and a lot of damage to the lives also. This was damage to the kind of a retaining wall and the road which was there. in the say just above the backfill of the retaining wall. That happened during the earthquake because the soil got liquefied and the soil was not able to support the road. And the same thing were also seen. You can see here the damages to the roads, damages to the ground. The ground is cracking heavily because of the liquefaction. That really occurred during the Bhuja earthquake. There was a widespread damage to the railways. Rail tracks were damaged. They were bent. The tracks were bent. These were made of steel, and that was totally bent within a few seconds. And even the sand boiling occurred. Sand boiling is a typical say phenomena which is occurring in the sandy silt, and where the water is rising to the ground, and along with that, the sand particles are also rising and appearing on the surface. What you are able to see here on the right top photograph. Now, where does the liquefaction commonly occur? Now we go into the little bit of depth. See. Out of all different, say, areas of soils, particularly different particles, clays, silts, sands, gravels, cobbles, and boulders. These are different sizes of particles of soils, out of which the liquefaction is happening where the silt and sand are present. So there the liquefaction chances are more. Now, in such soils, we can actually estimate the liquefaction potential. And there are a number of methods available. After 1964, the damage that happened at Niigata in Alaska, there were many research scientists who actually worked on this process, and they have developed the methods to estimate the liquefaction potential. How much potential is there with the soil to really get liquefied? And there are a number of assessment methods in the field, in the laboratory, and certain model tests which are available. And all these tests, of course, are available today, but some of the tests are being applied to the field, and some of the field tests are being used for arriving at certain idea about the liquefaction that is likely to occur at certain sites. So the same methods were applied to Ahmedabad also. There is one test procedure, standard penetration test, which is abbreviated as SPT, and there are two scientists at the University of Berkeley, California in USA, Sid and Idris. They developed one method in 1971, which is world level known as Simplified procedure for liquefaction potential analysis. That was applied to Ahmedabad also. And all these blue dots, which you are able to see in the map, the liquefaction analysis was carried out. And it was, say, concluded that with the Sid and Idris method, the liquefaction potential is not there at all these, say, locations. There was another method by Idris and Bollinger, developed in 2004. I had the good fortune to meet this particular person, Idris, who is now, I think, about 80 years of age. And we had actually organized one Indian Geotechnical Conference in 2005 at Nirma University in Ahmedabad. And we invited this person, I.M. Idris, from University of California, to come down to Ahmedabad to deliver the, say, conference lecture. And he say, accepted that invitation and was here for 3 days in Ahmedabad. And I had a good fortune to have some interaction with him. And he presented this method of Idris and Bollinger, which he prepared in 2004 for the first time at world level at Ahmedabad. That was in Ahmedabad in 2005 in December, that he first time presented his results before the world. And we use the same method here. And for Ahmedabad, again, it was derived from with that method also, that there are no chances of liquefaction potential. But with the one method of Andrews and Stokes of the shear wave velocity, which was developed in 1997, there were a few locations near the, say, city area and on both the sides of where you are able to see some red dots are actually showing some liquefaction potential. The buildings which are there are having the danger or the risk that during the earthquake, if the water table is there within the 15-meter depth from the ground level, then it can get liquefied and there can be a problem. Then the other geotechnical failure induced by the expansive soils. Expansive soil is a kind of a soil it is definitely highly problematic because it has got the capacity to undergo a significant volume change. See, the typical behavior of this soil is that they have the capacity to swell. They can expand during the rainy season when they absorb the water, a huge expansion of the volume. And at the same time, when they lose the water by evaporation during, say, summer, the same soil will shrink during the summer season. So it is the same soil. When it will expand, it will exert the swelling pressure. And if the foundation happens to be within the swelling pressure zone, then the swelling pressure is so great that it can even destroy the foundation which is constructed of concrete. Even the concrete will get turned into powder, right? So it can result in heaving of the entire slab, the ground floor slab. There will be a number of cracks which can form on the walls like this. The outer walls will just crack, and it will have tilting outwards. Even the bottom slab can rise like this if the expansive soil is happening there and it is receiving the water. And if it is, say, shrinking, then the reverse will happen. Then the slab can sink, the walls can tilt inwards, and there will be a number of cracks happening. So if this is happening, the reversal is happening every year, every season, then the components of the building will not stay, it will crack and it can collapse. Even the roads will have, say, ups and downs because of the contraction and swelling of the roads. There will be cracks formed in the building. Even the building components can be tilted. There can be certain solutions which we can apply here, but that part is, we have to go in detail. There can be a bearing capacity failure also. It is this kind of failure where you can see that the entire grain elevator, the silo for the storage of grains, was overturned by the bearing capacity failure. Bearing capacity is the kind of load supporting capacity of the soil which is supporting the building. But if that failure happens, that the soil is not having enough capacity to support the building, then the building will collapse like this. So the same kind of, it requires certain immediate, say, repairing, some immediate remedial measures to be applied. Otherwise, the building will remain totally useless. There can be some failures due to induced settlement, and the buildings can settle. That is a vertical downward movement of the entire building in the soil. If the soil is like that. Particularly the clay soils will have larger settlements happening. And if it is, say, settlement of the part of the building, then the building is likely to be tilted. And if the differential settlement happens, then the tilting may be associated with the cracks which are happening in the, say, superstructure. And generally the differential settlement, if it is exceeding certain permissible value, it may result in the complete failure of the buildings. So in all such cases where the bearing capacity failure is happening, or settlement failure is happening, or even the liquefaction failure is happening, we have to think about certain remedial measures. It is required, we must investigate the soil first. We must identify the group of the soil. We must anticipate certain problems if at all it is there. And we must take certain remedial measures prior to the construction. Then only it is safe. Otherwise, the building failures will happen and will not be able to save the lives of the people, will not be able to save the properties. And there will be huge damage in terms of cost also. I think I would like to end my session here. I've covered some of the, say, failures of the soils, and what are some of the remedial measures that we have done. Mainly, I have tried to cover some of the very common failures. And if someone is interested in knowing more about it, you are welcome. And with that, I would like to end my presentation. Back to Mansi Madam.
Oh, yes, sir. This session is open for question and answer now. So participants can ask anything. You can ask your queries to Sandip, sir. Or you can post your questions in chat box. So if anyone has any questions, you can ask here right now.
Or I would suggest if someone is having some question, you can take my email from Chintan Bhai and you can send email with your question. I would be happy to answer that.
Sure. So I
Sir,
have one
we
question.
have one question.
Yes.
I'll go after.
Yeah. So sir, Mumbai is मतलब develop besides of sea. So is there major chances to earthquake आने का ज्यादा chances है वहां पे अहमदाबाद से ज्यादा या वहां पे ऐसा नहीं है मतलब कुछ सॉइल कंडीशन की वजह से वो एक डाउट था.
See, for Mumbai, I'm aware of some of the risks which are there. Few parts of Mumbai are actually reclaimed zone, which are actually filled up soil and compacted well. And these reclaimed soil zones are also having huge buildings. Some 10-story building or 20-story buildings have been constructed there. There were problems with these buildings that they started settling down. And they were exceeding the limits of permissible settlement. And so immediately some remedial measures were taken. And they were like provided with some micropiles later on. And the further settlement was stopped. So some of such problems occurred there. But because of the earthquake, immediate danger to Mumbai is not there. Yes, if there is earthquake in, say, deep sea, there are chances of tsunami to come, and which can really result in a lot of damages because of the flooding in Mumbai. But the other problem that is going to happen with Mumbai in a very near future, what I mean by near future is, say, a span of about 30, 40, 50 years, is the rise of the sea water that is going to happen. And which we are fearing a lot because the seawater level is rising. And if it is rising, say, even by 20, 30 centimeters, then it will spread in the various areas of Mumbai. And that will submerge some of the areas. That is going to be a big problem. And as such, also, the drainage system of Mumbai is such that there is not proper, say, gradient that is available. So sometimes the water which is sent to the seashore, it is actually coming back, and that backwater is entering again in Mumbai, and that is also not capable of handling that storm water too. So there are more problems with the water. It's not because of the earthquake. It is because of the seawater level that may cause problems in Mumbai.
Okay, thank you, sir.
Srinath, you were about to ask something, I think.
Yes. So sir, is there? I know about this one test about the buildings where there is for models when the architecture students are making the buildings. Then there's this shaking machine where it shakes to test the horizontal gradient. I mean the horizontal movement of the building, whether it can sustain or not. So is there a similar test for the buildings where they can see that? Like the things you told, like the buildings can shrink inside, like the other test, are there any other, like if suddenly the water level rises, can it, I mean, such tests are there so that you don't have to like actually.
Shake table is a wonderful device where we are capable of developing certain similar kind of situation, providing certain similar to pig ground acceleration, and we are able to test some of the building models. We have also done testing for the liquefaction. We had fabricated one tank, and we did some liquefaction studies for the tank, which was filled with silty sand and then was provided with water. And we also caused certain shaking there. And yes, it will definitely give you certain conclusions for a different range of, say, acceleration that you are providing. But now what I was started feeling that the realistic studies are far more important than the model studies. The studies that you are conducting on the natural soils, the natural structure of soil, the particles, the groundwater, the combination that you are having, it is better to go to the field and conduct some field test over there. Like the test which I just mentioned, the engineering seismograph that you take over to the site, or the micro-tremor test that you are conducting there. It is better to test the soil the way it is existing in the natural strata, right?
Okay.
Rather than, because it's very difficult to simulate the structure, the way the particles are arranged, because once you destroy that structure, when you are remolding it for the say model study, number of parameters will change. So
True.
it may not give you the correct idea. I've seen some of the model studies results going totally wrong. So it is better to perform the actual tests. Of course, the availability of the equipment is really a problem. We don't have much equipments here in India. Of course, now many of the IITs and NITs are purchasing such equipments. But still, ISR is the only institute where some of the very advanced equipment like ground penetrating radar is there, and many other very advanced equipments are there. So, but still, we definitely have the technology available.